Alrighty, folks. So we have our stock solution, and you know what? We want to make a solution that is a little less concentrated. And this sort of thing happens, like if you say you have like a Gatorade concentrate and you want to make a liter of Gatorade, and you have the super concentrate, you have to figure out how much of this to add to how much water to get the solution just right. So let's make a new solution. So let me show you how to dilute. I'm going to show you the I'm going to show you the math, and I'll show you the easy way, and then I'll explain why it works. All right, so first things first, we have our stock solution, which we'll call solution 1, and we're going to dilute it to solution 2. You see there's less particles per volume, so this is like our Gatorade. This is our Gatorade concentrate, okay, or fruit juice concentrate, whatever we want. So we want to dilute a solution using our stock solution, and we figured out from previous that our molarity of the solution is 0.925 molar NaCl, so that's moles per liter NaCl. So we want to dilute our stock solution, that many 0.925 molar NaCl, to make, let's make the same volume, 200 milliliters. So we'll call that V2 for V for our second volume. So this is V1, this is V2. Of 0.100 molar NaCl solution. So what we're going to do is we're going to go from 0.925 to 0.1. So that's like almost a 10th dilution. So this is M2, this is M1, and we want to make a more dilute solution. So let's figure out how to do it. I'll give you the preview and then we'll do it. The first thing we're going to do is we're going to be using the function that molarity is moles per liter. And when you multiply it by volume, which is liters, it gives you N, the number of moles. See how liters cancel moles? So to find the moles of a certain solution, you multiply the volume times the concentration in molarity. This is why we use molarity so much, because it's an easy way to convert between liters and moles. And we really just care about moles in chemistry, okay? But let's pause for a second. Let me just show you the quick way to solve these problems with the equations. So here you go. Boom, boom. All right. So knowing that, it's nice little lighting over here. Knowing that the concentration of the molarity of one times the volume of the other equals to the moles, it turns out that you can, to make a new solution, what you do is you set up this equation. This is your molarity of your starting concentration, your stock solution, and the volume of that. So how much of that do you need to get a new volume and a new concentration? So say if you're solving for Gatorade, this is our 100, say our 1 liter, we needed to make, or maybe a glass, 200 milliliters of our new volume, and we want it at a certain concentration. How much of this at the higher concentration? And you can imagine that this is a smaller number, and it makes sense in that if you have a lower concentration times volume, you're going to get a certain number of moles. To get that same number with a high concentration, you have to have a smaller volume. So conceptually, this equation can make sense. So anyway, you go M1V1 equals M2V2. The book uses M stock times V stock equals M diluted to volume diluted, same thing. I put in my starting molarity of my solution, 0.925, my stock solution, and I don't know how much of it I need, but I do know that I want to make M2, which is 0.100 molar NaCl, and I want 0.200 liters, so 200 milliliters. Solve for X, and I end up with a volume of 0.0216 liters. Convert that to milliliters, it's 21.6 milliliters. So in order to make the solution, I need to add water to about 22 milliliters of stock solution until the total solution is 200 milliliters. Okay, so let's do that right now. Let's make it and then talk the math. Okay, so here is my stock solution. I'm going to pour it in here because this is my more accurate thing. If I was really going to be precise, I would just wash this darn thing, but here we are. Okay, and I'm going to measure in, I said what, 22 milliliters of this. I'm going to use the balance because the balance, it's almost pure water, and the density is about the same as water to 2 milliliters. So measuring out 20 grams is about 20 milliliters. And I'll look at the side of my container to see how well they align. For really concentrated solutions, you can't make that assumption anymore that, oh, a little over, oh well, what are you gonna do? Okay, actually, let's pull a teeny bit out. I'm just trying to be precise here. What did we say? 21.6 milliliters. I know. I say perfection is the enemy of getting your shit done. Wait, oh, what? Magic? I think some got absorbed on here. Oh, all of a sudden. Anyway, 21.6. That's pretty good. Do I mess with it? Oh, so yeah, there you go. Perfect. Okay, good. So this is my stock solution. There it is. All right. So what I'm going to do here is let's dilute it to 200 mils. Just going to put I'm looking at my graduated cylinder on the side. And it's important to measure the volume until it's about 200 mils. I'm going to use the volume this time. So let's take a look here on the side. Take a look. Oops. Let me just get in the way of what I'm doing. All right, it's about 200 mils. I don't feel like looking at it on the edge. Close enough. So you see the balance is a little bit different. So it's probably these lines are not that accurate. A good way to do is when you have a graduated cylinder or something like this, you can actually calibrate it with pure water. So you can even turn a regular cup into a measuring cup by just adding 100 grams, 200 grams, and marking it at milliliters. So FYI. So here's my new solution. Okay, so this is my new stock solution at 0.100 molar, 200 milliliters. The reason why all that math works is that, back to this, is that molarity times volume is equal to the number of moles of NaCl. So what I did is that for my new solution, I have 0.100 molar and 0.200 liters. That means I need a certain number of moles of NaCl. So these little dots here in my new solution. And then how am I going to get it from here? Well, I know I need to just kind of cut out a chunk, but how much of it do I have to cut out? So because the number of moles that I need is the same, so I put N2 equals N1 equals V1 times N1. So this is all my stock solution. So to find the volume of that particular, the volume of solution I need to get that many moles of solution, I rearrange for volume equals N1 over M1. And I put in, this is how many moles that I actually need, because I did the math here. This is how many moles of NaCl I need. And this is moles that I need divided by the molarity of the solution. See how the moles cancel and get liters. And the molarity of my stock solution is 0.0925. Put it together, and you end up with 0.0216 liters of stock solution, which is the same thing that we got over here. And this really harkens to the fact that if you solve for the moles of one, the moles on the left has to equal the moles on the right. The moles you add in equal the moles that you start with. And that's the premise of this equation. Once again, M1V1 is equal to N1, and M2V2 is equal to N2, and they're all the same. So that's how this equation works. All right, good luck.